In this video, we'll go through questions 1 through 3 from last year's Quiz 2. This is a menu pricing problem, so the topics from Class 4 will be relevant for solving this problem. In this problem is a company, Zpeds, that rents out hours on their moped service. There are 3 types of customers: couriers, tourists, and residents, and they differ based on how much they're willing to pay for an hour of service. They also differ in how many people are in each group. The couriers have 100, the tourists 300, and the residents 700. Now, the first part of this question asks, if Zpeds charges $25 per hour, that's a fixed price that's given to us, what's the resulting revenue, total consumer surplus, and total deadweight loss? So let's walk through how to solve this problem. The first thing to notice when solving this is we're given the marginal willingness to pay. So that's how much for each incremental hour the customer is willing to pay. So for the first hour, couriers are willing to pay $110, the second $80, the third $50, $40, $35, $20 as we go through. So to determine how many hours that customer will purchase at $25, we just compare their marginal willingness to pay to what they have to pay, the $25. If they're willing to pay more than $25, they buy. If not, they don't. So let's start with the couriers. But by the first hour, right, 110 is greater than 25. They're willing to pay 110 for it. They pay 25. So that's 85 in consumer surplus for them. We'll keep track of that in the bottom. Well, by the second one, right, 80 is greater than 25. So that's another 55 in surplus. They buy the third, 50 is greater than 25. That's 25. They'll buy the fourth, 40 is greater than 25. That's 15. And they'll also buy the fifth, 35 is greater than 25. They get 10 from that. So all in all, they'll buy 5 hours, right? Because the 6th hour, they're willing to pay 20. They'd have to pay 25. That's not worth it to them. They don't purchase that 6th hour. Okay. So total purchase for the courier group, they'll buy 5 hours at $25 per hour, and there are 100 of them. That's the revenue from the couriers. Okay. Consumer surplus we just solved for. It's 85 plus 55 plus 25 plus 15 plus 10, which all adds up to 50, 105, 190. And deadweight loss is any hour they don't buy when they have a willingness to pay above cost. In this case, the marginal cost is 0, so there's 1, and that was $20. So deadweight loss is 20. We do the same type of analysis for the other groups. So tourists will buy the first and second hour, $30 better than 25. 25 is greater than or equal to 25. Tie goes to the company. Okay. So for the tourists, we have they'll buy 2 hours times 25 each times 300 of them. That's the revenue. Consumer surplus, we have 30 minus 25. Okay. That gives them $5 in surplus. They're just breaking even in surplus for the second, so we don't count that at 0. So that's consumer surplus of 5 for them. And then the deadweight loss are all the hours they don't buy, even though they're willing to pay above 0. That's 20 plus 15 plus 7 plus 3 is 10, 25, 45. Okay. Now we go back and solve for the last one, the residents. See if we can squeeze that in here. For the residents, they're willing to buy the first hour at 25, so the revenue is going to be 1 times 25 times 700. Everything else is less than 25. Right? Consumer surplus is 0, because they're willing to pay 25. They pay 25, and then deadweight loss comes from hours 2 and 3, the 12 and the 5. They didn't buy, but they're willing to at $17 in deadweight loss. So that's how we solve that problem. To get the total numbers, you just sum everything up. Moving to question 2. Okay. We're given the same marginal willingness to pay table. Now we want to calculate the optimal price and revenue from this table. Let's do that now. This is pretty straightforward as well. So let's take a look here. Couriers willing to pay $110 for that first hour. So this one. There's 100 of them. So if they sold at $110, which is the best they can do, they sell only to couriers, they get revenue of 110 times 100, which is the group size. That's $11,000. Or they could drop the price to $30. They pick up 300 extra customers, so they have 400 total, the couriers plus the tourists. 400 times 30 is 12,000. That's better than the 11,000. They would never sell at 110. They're going to keep going. One more to check. They could drop the price from 30 to 25. They'd pick up 700 more customers. So for that $5 price cut, they get a lot more customers. Would they do it? At 25, they'd get 1,100 customers total. That's going to be in the 2,000 or so range. I'm sorry, 20,000 or so range, better than the 12,000. So they would do that. That's their best price, 25, and they'll make 25 times 100 plus 300 plus 700 is equal to 27,500. That's their best price. We're going to do the same analysis for the rest of the marginal hours. At $80 for the second one, they could pick up 100 customers, so 8,000. If they drop the price to 25, they pick up 300 more. 100 plus 300 is 400, times 25 is 10,000. So they prefer that to the 8,000. Or if they kept going, they pick up another 700 customers. So they'd have 1,100 total. 12 times 1,100 is 1,320, better than the 10,000. So they do want to drop it all the way to $12 for that second hour, and they'll make $13,200 in revenue. Continuing for the third hour, if they have the price of 50, they'll sell to 100 couriers. They'll make $5,000 in revenue. If they drop the price to 20, they'll pick up 300 extra customers, and they will make 8,000, better than the 5,000. So they keep going. If they drop the price all the way to $5 and sold to all 1,100 customers, they make 5,500. That's less than the 8,000 from selling at 20. So they don't sell at 5. They stop at 20. They sell to 400 customers, the couriers and tourists, and then they pick up 8,000 in revenue. So now we're done selling to the residents. You wouldn't anyway, it's 0, but they're done from our calculations, and we can keep going. For the fourth hour, they're comparing 40 times 100 versus 15 times 400. So 4,000 versus 6,000. They want the 6,000. That's 15, 6,000 down here. 35 times 100 versus 7 times 400. 3,500 versus 2,800. They want the 35. So we're done with the tourists. 35 and 3,500. And the last one, 20 times 100 is 2,000. So that completes the table. That's all they asked us to do on this one. And we'll then finish up on the next page. Here, after going through that menu, we construct the optimal prices for each choice and they indicate the number of hours Q and prices P and the total revenue generated by the optimal pricing menu. Well, we did all the work in the previous question, so we can just fill those columns in here. We're going to offer 3 packages, a 6-pack, a 4-pack, and a 2-pack, right? And that was based on our analysis, right, from here. Remember, we circled those in the previous questions. So the price for those, for the 2-pack, we're going to sum up 25 plus 12 is 37. And the residents are going to purchase that. The 4-pack now will be that same 37 plus what they can sell to the tourists for the 3rd and 4th hour. That's 20 plus 15. That's an extra 35. So they're going to price the whole thing at 72. And then for the final 6-pack to the couriers, we have the 72 from before, right, because they're going to buy the first 2 and then the second 2. The third 2 will then come at an incremental price of 35 plus 20 is 55. And that's equal to 127 for them. That's our menu. Total revenue then will just be price times quantity, 127 times 100 couriers plus 72 times 300 tourists plus 37 times 700 residents, and that all adds up to a grand total of 60,200. That is everything this question asks for. Those are questions 1 through 3 from the fall 2016 quiz 2. That's all we have here.